going live বুলি আহি আছে ৰ'ব হৈছে এতিয়া হৈছে
কেমেৰা দিলে মোক কেমেৰাটো আৰু নচল নাই
দেখিছেনে আপুনি
ওই এক্সটেনশন কেবল তা না কি এক্সটেনশন কি হবে না এই ক্যামেরা এক্সটেনশন কি লম্বা না কিনা পাইলা এক্সটেনশন কেবল না ক্যামেরা ও বাইরে দেখা পাবে ঠিক দেখা পাইছে NSESAS তাও না এতে মোবাইলে রাজা Hello. क्या নালগে ডাঙৰ আছে ভালে আজি সমান হৈছে না চাম পুৰা সমান কৰি ৰাখিছে মাজৰ পৰা সমান কৰিব পাৰো মই সাইজৰ পৰা নলওঁ আবার ফোন
ইউটিউবত লাইভ চাবচোন লাইভ হৈ আছে নাই আছে যতলৈকে ষ্টাৰ্ট কৰি 1 ঘণ্টা ভিডিঅ'টো ডিলিট কৰিব লাগিব মই যেতিয়া বুলি বুকিং আছে খালি সাইজৰ পাই দি আছে যদি কমত এই কুলিটো এই ৰাউন্ড কমত সাউন্ড নাই আমি সাইড করতে দেখব এইখিনি বস্তু আপুনি নিব পাৰিও zoology both sides. Format exam to yesterday.
Esteemed delegates, Professor Yogesh Chandra Kolita sir, Professor Siddharth Chakravarti sir, Professor Subodhi Sahoya sir, Dr. Punokamal Senapati sir, esteemed delegates, faculty members, participants, and my dear students. A very good morning and welcome you all to the day 2 of our National Seminar on Environmental Sustainability Awareness and Solutions. We hope you had a refreshing start to the morning and are ready for another day of insightful discussions. Before we get started, we would like to felicitate our esteemed delegates as a token of our deep respect and gratitude for their valuable presence and contributions. We would like to felicitate Professor Jogen Chandra Kolita sir from Department of Zoology, Guwahati University. I request Honorable Principal Sir of Surendas College, Autonomous, Dr. Kiran Kumar Sharma, to kindly come forward and present the felicitation. Thank you, sir. Next. Thank you very much, sir. Next, we would like to felicitate Professor Siddharth Chakravarti sir from Department of Mathematics, IIT Guwahati. I request our principal sir to kindly come and present the felicitation. Thank you very much, sir. Now, we would like to felicitate Professor Subodhi Sahoya sir from Department of Geography, Guwahati University. Thank you very much, sir. Next, we would like to felicitate Dr. Kulakamal Senapati, Senior Technical Officer, Department of Chemistry, IIT Guwahati. Thank you, sir. We thank all the delegates for being here. We also have Principal Damdama College among us, and we would like to felicitate him with a Fulan Gamasam and a memento. Thank you, sir, for your presence. Let us now begin the technical plenary sessions scheduled today. Before we begin, let me acquaint you with what is going to happen shortly. We will have the plenary session 1 for day 2 at the current venue, and technical session 3 will be held at new conference hall. Dr. Kulakamal Senapati, Senior Technical Officer, IIT Guwahati will chair the technical session. I request the participants to join accordingly. Our first plenary lecture of the day is on community participation and environmental awareness by Professor Jogen Chandra Kolita from Department of Zoology, Guwahati University. Professor Jogen Chandra Kolita is an eminent academician and researcher in the field of zoology. currently serving as professor and head of the Department of Zoology at Guwahati University. He completed his MSc in Zoology from Guwahati University with a first class and university gold medal and earned his PhD from King's College London, University of London. Professor Polista has over 29 years of teaching experiences and more than 3 decades of research experience at national and international levels. As a recognized PhD guide, he has supervised 28 research scholars to the award of the doctoral degree and continues to mentor emerging researchers. An accomplished scholar, he has authored more than 120 research publications and 6 books in areas spanning animal physiology, biochemistry, and environmental biology. His work has been enriched through prestigious fellowships, including the Commonwealth Academic Staff Scholarship and the Leverham Trust Postdoctoral Research Fellowship. And he has participated in academic engagements across several countries. Professor Kolita's contributions have significantly advanced scientific understanding and academic excellence in life sciences. It is my honor to invite Professor Kolita sir to kindly deliver his lecture.
Hello. So a very good morning to all of you. As many things have been talked about myself, I am delighted and I congratulate all of you. Special congratulations to our principal, Dr. Sharma. I went through the development of this institution. Everything is in here to the level of the autonomy. So therefore, another congratulations to college authority, and I thank all of you for inviting me to this particular workshop as a speaker. I think I will be getting how many minutes? 45 minutes too long. I think I will minimize it. So many people, speakers are there. Esteemed delegates from other part of Northeast. I can see from the Solanki, and with whom we have been working for. So caring principality. He has been taking that for me. You see, everything you have noticed that so caring. I do not take more time to address all of you because all are waiting to do their own job. They have some, okay, Indian scientists will share their papers, Dr. Senapati, and others will speak. And it is really multidisciplinary. And also our problems are many. I will be talking about one problem. I work on endocrine disruption. It means communication disruption. When we have problems with any mobile connection, then we get annoyed. Like in this environment, we have problem with our internal connection with the outside connection. Two systems in the body normally perform that particular kind of action, how we interact with you, suppose I am talking and interacting, and how we interact with the other outside environment. Two systems, first one is nervous system, that is all of us we know, and second one is the endocrine system. Nervous system is the networking system in the body inside, but another system, endocrine system, that controls us with their secretion, and those are hormones. Endocrine system secretes hormones in tiny quantity, but action is so precise, very distinct and clear and perfect at perfect time. And when there is a discussion or disruption, that part I will touch. I will talk about how normal system, when it is going on, how things from environment can affect us and disrupt us. And from the picture, all of you can see that we are in the hormonal chaos. So many chemicals in the environment coming from the industry, or something coming from the industry to cure our problems, or to give the benefit of the to humankind. That man-made chemicals having problems has been established. That though we created them for our welfare, but they are creating problems to survive. So human race is at a problem. Even our fertility to continue the race, reproduction, all are in problem because of the chemicals what we use today. And herbicides at your campus or at the campus of the college, pesticides everywhere, mainly in the tea garden, tons of pesticides used, and many chemicals are in the home kitchen. When we use detergent in it, all of them are having some kind of hormonal effect. And problem is how to know. Problem is how to determine. Many of my research scholars are sitting here. They work on some of the chemicals and accordingly they submitted the thesis, got public awareness, also they got degree. And I think my data was taken from the Google, it was not updated. At present, I clear 30 plus PhD scholars. So, what I talk about, everything endocrine disrupting chemicals. What are those chemicals? Those chemicals are environmental chemicals. They are coming from the environment or the market or anywhere. But we need to use them to get protected from some kind of other effect. Like in agriculture, we need to have some kind of insecticide. We use those chemicals, but in return, they are causing harm. They target reproductive systems, mainly, and in development, and also regulation of our communication. And if that is disrupted, World Health Organization again warned all the people in the world, maybe the scientists, that please do something. We need to get protection. This was one incident that from the nature, when this fish population, farming, got affected in Australia, then it was debated in the parliament that farmers were got problems and to the level 100 coming down to zero. When it was debated in the parliament, they requested Oxford University professor to study. When government requested Oxford and Cambridge professor to study, like how we invite experts today, they studied that particular problem. Why fertility was decreased, infertility was there, it was very much, and the population got declined. Farmers made human cry. At that moment, those scientists from prominent universities in the world discovered the chemical in the grass on which those fish populations was fed. So that grass was called clover, and name of the disease they declared as clover disease. What is clover disease? The disease produced by the fish, given to the populations of fish in the farms, and infertility is developed, and we had problems. And that problem was debated, and also paper published, got published that the culprit was discovered. Culprit was a chemical. So like that, we have many chemicals we use in the environment, or many of them are coming from plants, but they create problems. So like that in one lake in America, people noticed that alligators, they were in hundreds and thousands, but suddenly population got declined. They wanted to know what had happened, and finally it was discovered that during the World War, 1945 around, all the DDTs used across the world, they got back to America and those were dumped into the Lake Apoka, Great Lake, like our Sinop Lake. And when they got into the ecosystem of the lake, then immediately population of alligators declined. People and the visitors and the tourists coming from the world, they could not see alligators normally. And again the issue was debated in the parliament because they are very much concerned at that time, it was great concern. And they discovered the chemical and environmental chemicals coming through the military actions, dumping in the lake and chemical was DDT. Then immediately metabolized into DDE. So DDT got metabolized into DDE and those chemicals affected fertility of alligators. And they considered them as endocrine disruptors. And it is multidisciplinary, I am not getting into the mechanism further. But I want to tell that this is a problem in our environment and World Health Organization looked into it as a serious problem. They say that environmental quality is one of the key factors in determining whether a child survives the first years of life. That is a problem mainly in the third world countries. And they noticed that many of the children, they die even if they are not crossing 1 year. According to the publication from third world country, I have said, they were concerned in the first world country. And they put more money to decide what to do and how to do. All organizations I have named here, all are there. UNEP, UNICEF, WHO, etc. All got involved in endocrine disruption studies. And endocrine disruptor, the word endocrine disrupting chemicals came into existence in 1993 only. So it is the art of science and that is new. 1993 onwards, it has developed. As I say, our system of communication, networking, everything depends on the natural balance. If we are at a balance, then no problem with our memory, no problem with our communication. It is internal as well as external. But if any chemical is coming into our body and they are causing any harm in the balance of our system, like I am showing here in one model of menstrual cycle. During menstrual cycle, these are the hormonal signals and these are the level of the hormones right from day 1 to day 28. It is a normal cycle. Signal coming from the hypothalamus in the body and that brain hypothalamus pituitary, then ovarian hormone acts on the uterus, then we get all the hormones in our blood. When there is normal, then no problem. Pregnancy will be normal, children development will be normal. But if there is any problem with intricate balance, there will not be ovulation, there will not be fertilization, there will not be infantilization, no pregnancy, and fertility may be there. So these are the problems in the mechanism. I want to tell you that it is in the brain and in the systemic level, the ovary and the uterus and everything connected to environment. So environmental factors are very important and this one small molecule, I have shown you the third side. It is a decapeptide, only 10 amino acid molecule and coming from the hypothalamus. It has controlled everything. It has been controlling everything related to that. So therefore, if anything coming from the nature can cause an imbalance of the level of that particular molecule, everything will be abnormal. And in male also, in the testes, nowadays you find that fertility, now we talk about infertility. A time was there, I was studying New Delhi at that time, 1986, that people talk about control of fertility. Now people talk about sterility. That sterility has gone to 8% now, and it is in many of the countries more than that. So if that is the case, we find many couples without any issue. So those are the issues. People, mainly the scientists, they are targeting the environmental chemicals and they disturb at different levels. I am showing you here how the system can be disrupted, and therefore, when we talk about the cement quality, it has been lost. Sperm count not adequate. So like the lowering of sperm count due to the interference or the interference with environmental chemicals has been an issue today. And people are looking at the chemicals which are coming from the outside and causing harm to our internal environment, even in the production of the hormones and the production of sperm. This was the scientist for the first time in the world. He talked about that all our three mediums, air, water, and soil, all were contaminated by industrial chemicals. And when she talked about that, she was bitten by the industry. At that time in America, she got bitten. Why she talked about cooling with the nature? That was the question of the industry people. She talked about cooling with the nature. It means our normal system has been decooled by chemicals coming out from the environment to our environment, from our roots, like through food, through skin, official applications, and thereby causing problems. He was again, but American president that he could save us from so many cases filed against us because he wrote a book, Science Free. That was the first book in the world to talk about the environmental chemicals and problems with humans, animals, wildlife, everything. Then so many years went on. Another book in 1996, it was published, Our Human Future. Are we threatening our fertility, intelligence, and survival? A scientific detective story. And when it got published, I was in London at that time. My professor told me, you act on this, you work on this, do research on this environmental problem. Therefore, I started by saying that my area is endocrine disruption. And in that book, those authors, three authors combined and also pointed out to the chemicals which are causing this problem, and coming from the main source was industry. As I said, the environmental chemicals, they are termed as endocrine disrupting chemicals. They are chemicals which are available in the external environment, and we know them, we use them, knowing that they are not good. Why? Because of mosquito control. We have lots of mosquito, unlike Western countries. In London, no mosquito. In India, lots of mosquito. We need to control. No way out, we need to use some chemicals. The chemicals are causing problem in our communication. And when we talk about environmental health, when we live our environment, in our environmental health, then we talk about how the environment influences human health and disease. So that part is also included here. And in here, if you see, right from before birth and also till birth, all these chemicals are playing with us. We take in different forms. I am going to show you how they are affecting our development and also in aging. How aging are affected by some of the chemicals and also diseases like Alzheimer's disease. Okay, all kinds of related to memory. And endocrine disrupting chemicals, they enter through roots, and many a time we take them in the form of chemicals and also eat them from natural sources where chemicals are deposited as pesticides in our cabbage, in our tomato, and also many other vegetables. And therefore, World Health Organization talk about dark ozone being 12 very highly used endocrine disruptors, and we need to control them. And when we publish paper, they are getting into the policymakers also. In the national seminar, this one, these recommendations should go to the policymaker. And obviously it will go. And endocrine disruptors you see everywhere. In the form of bacteria, what we use, where are we at? In the form of heavy metals we detected from our deported Ramsar site. One of the studies of my students, I am not showing it in here. Deported water, or salami water, and on Borolo River water. There are very many heavy metals, and those are characteristically studenic. Studenic means they are act like students. And student our female major hormone, estrogen 17 beta. If that hormone receptors are already wrongly bounded, then there will be problem. And this chemical, the people ask. Again, I am showing you that some of the problems, stress, infection, malnutrition, pharmaceuticals, environmental chemicals, all are the problems which are influencing our health and our other diseases. And one organization, Swedish Environmental Longitudinal Moderate Science as per studies. So they also pointed out what I have mentioned here, that 70 years, 30 years, 20 years, 10 years, 6 years, we mean malformed baby time. Malformed, okay, the 90 years. So all these problems are reported from various laboratories in the world. And when they are coming to the notice of the scientists, we cannot wait. We need to act. So here you see 3 generation exposure. Suppose if you talk about DDT, if one lady is exposed, then immediately the fetus is exposed. First generation, the mother, fetus second generation. Reproductive cells in the fetus, third generation. So that way, generation to generation, effect will be exhibited. If you are exposed, if a pregnant lady is exposed to some of the chemicals in tiny quantity, they will act like hormones inside the body. How they act, they will take over control of the receptors of the hormone. Like estrogen hormone. Estrogen hormone receptor, they will catch up. And immediately there will be abnormal development. And low dose controversy. People talk about that, they are so low, how they affect. Low dose controversy has been resolved. That our hormones are also nanomolar concentration. So at a very low concentration, tiny amount, they work. There are many coming from many thousand chemicals in the world. We cannot avoid some of them. There is the chaos. So we need to discuss about the chaos. Even the baby bottle, baby milk bottle. Okay, if mothers are so happy, the bottle is good, but there are problems. So how to avoid? Use for 1 month only. Then take the new one. Mineral water bottle, no use second time. If I have to use at all, if you do not use good. If we are to use at all, then use it for once only. It is immediately we can remove. So as I said, that there is sexual development inside your mother, inside mother's body. Well, the fetus develop, and developmental stage is very, very important because all the windows are open. Then endocrine news already alerted us. What is that? Are these chemicals destroying your fertility? That was the question in 1996, Daily Mail, London. And I was a researcher at that time. So we got very interested in that news. Then they say the sperm count is going down. Many of the males are mainly Western reports as well. So many of the males were infertile, but they were studying the female counterpart. So those were the things also. Psychology was at that time, psychology defended them. Why so? And look at society across new beauty product regulation. So many products we use like nail polish, our cosmetics, and European Union, they put some regulations on that. How to use, and they suggested only the branded one. So you see let the sunshine things. You studied illuminate vitamin D, importance of that. So many things are there, the chemical, interact with chemical cell to cell talk, and we find the execution of the action. And also early life, like bisphenol A exposure, reprogramming gene expression linked to fatty liver diseases. It's a very common disease nowadays, fatty liver. I think very common nowadays in Assam. So they are linking one chemical directly. Study 12017. Okay? British Medical Journal, they reported that this is happening. Also, there are many reports exposure to common gene retardant raise the risk of pituitary thyroid cancer. We talk about reproduction, now we talk about thyroid, parathyroid, and also gene diseases, cancer, endometrial cancer, like that. So another chemical, I do not want to go detail into this. So many chemical reports are coming. Chemicals, how do they influence? Because the chemicals coming from the industry, they are very much similar, 99.9% similar with our hormones. So that is the point where they are getting the advantage. As they are 99.9% similar, recoding can be very easy for them. How they are coming? They are coming. So the roots I already talked about them. I'll show you also. These are the roots. Our nail police. Our skin is permeable to those chemicals. They are our hormones are steroid, but they are not steroid. Now, what is the quality of steroid? Steroid can pass through our skin because they are low molecular weight, and those chemicals are also look like steroid and low molecular weight, not heavy molecule. So they can get into through our skin into our blood system, getting the target organ, they try to see take connection with the receptor, and if they get the receptor, if they control the receptor, that will be negative way of development. So secondly, you see in plastic package, foods are coming. Also in the kitchen, microwave, we sometimes use many a time we use microwave and also plastic bag. If that is the case, then some of the chemicals get converted to another one, which is very dangerous. Many of them are preservative. PPA I talk, they are preservative, your cosmetic tube. To preserve this particular your content of cosmetic, we need to use BPA, bisphenol A. It is protecting, therefore expiry date you can write 2029. Otherwise, if that is not used, it is difficult to protect your content. So that way, commonly, many are there, and this grape, package of grape you see, the plastic they use, and also some chemicals. Why they use chemical? It is coming from suppose Kashmir, coming to Kolkata, then to our Guwahati, we go to Nagaland and Mizoram. It's a long way, and they are already those grapes will be infected with some of the products which are used as industry. I already said that it mimics. If Sugan Kolita is talking in here, if Duboviti Soria takes my position and mimic, then you cannot differentiate whether Sugan Kolita is talking or Professor Duboviti Soria is talking. So that is the kind of mimicking. Sometimes they stimulate, overstimulate, sometimes they block. So these are many, I do not enter deeper. And as I said that environmental quality, you see the fetal period is important for chronic diseases later on in life. So those that scientists he did research and he talked about how some of the chemicals is there with us during development. Even long run, after many decades, they will be creating problems with deadly diseases. And also Pitas is shown here that they are having problems with environmental chemicals. And also neurons, I talked about in the beginning, neuron development is very important. The whole networking system, if it is affected in early life, there will be so many difficult situations in life. One example, I am talking from the chemical side. It has not been considered as endocrine disruptor. But what was happening? You see, thalidomide disease. I am talking about this. What is the time? Look, Samita, how many minutes I have?
Sir, 11.
How much time I have taken already? Tell me. I did not look at it.
So you can have 10 more minutes.
10 more minutes, actually. I'm very much concerned about others. I should not include to other times. So thalidomide, this was the strategy. It was the chemical which was used to cure leprosy. Leprosy got cured. People said that, no, it's a wonderful drug. Then somebody said, no, we can use this and to regulate the morning sickness of pregnant ladies. They minimize the morning after sickness, sickness. So therefore, it was also given as a tablet. And all these ladies who used in millions, they were very much happy because chemical protected them and given the comfort that no morning after sickness. Wonder drug and also safe and sound sleep, no problem. Till that it was good. And when doctor observed fetal development, ultrasound studies showed that many of the maximum of those babies developing, they were having problems. And that will accumulate in future. So they detected the fetal development stage, and when they were born, it was so dangerous. Okay, that had happened. In this world, we have stories like this. So therefore, when we use chemicals, we need to be very careful. That was the message given by that study. And the families were a very good situation because no remedy. You see the problem. So the chemical was wonderful chemical. All millions say that it is wonderful drug. We could sleep well. We could get comfort from morning after sickness. But the chemical working different. And the problem was discovered that it was not perfectly tested. So therefore, in science, what we do, we take some kind of pilot study and also some kind of scientific trial. Trial number 1, trial number 2, trial number 3, then to the doctors or prescription. Another example is mast cow disease. All of you know that cow got disease and they behave abnormally. You cannot go to the side of the cow. And also it was the chemical affected their brain. And that chemical, what was that? That was a chemical given for food. Because they wanted that one cow should be like 2 quintals, 3 quintals, because it's retail. Beef is a good product. Everybody from retail, they sell out beef to across the world, Russia or America, everywhere. And they accepted it also, very nice. But when it is big, the cow developed that kind of disease one day. In 1998, Parliament banned it. Parliament said that this is banned, nobody should do business, then economy suffered. Then they put money to study what happened. And finally they found after 2 years study, to not do 1 year study because scientifically very sound university country. So they say that Putin was formed wrongly. Putin was synthesized wrongly. And that protein was synthesized because of the forceful feeding of some kind of animal product which was researched into the text. So that has happened, very good tragedy, and finally that also came to human being. And as a chemical that affected the brain of the human. And the scientists said that it is CJD, human form of mad cow disease. And when that was discovered, again they put more money to do more research, and they could save lives of millions of human beings, not to talk about cows. So what are the problems? Problems taxing in danger. That our production centers, farm and ovary all are in problem, reducing sperm count, also remedies are there. What they say, that marijuana from India, maybe from Nepal, also from Bhutan, they did research and they found that it has possessed some chemicals which are having some problems with memory, cancer, road to drug addiction. So many things are there in nature. We need to study them. What they found that the chemicals in marijuana, ganja, they are also taking the course of the endocrine disrupting chemicals. But when one in seminar they asked me, what did you do? I said nothing. Because from our part of India, no result was there. It was from Holland. It is not that only human beings are affected. You see, gastropod, molar, they are very important for environmental control, habitat control. All we need them. Right from the bird they are flying to the microbes they are in Kaziranga soil. We need all of them. But they are in problem because of the use of some of the chemicals which we do not understand, we do not know the mechanism. All everywhere. Therefore, I use the term chaos. And hormones are in environments. They are getting into us, creating a chaos. We need to take care of the chaos. These are our studies I am showing you. As I said, we could detect the problem. My research scholars are mostly ladies, and because nowadays all the boys they are getting into so many services. So therefore all the cards they do research. Already I guided more than 30 PhD scholars and 25 of them are girls because they are very good in laboratory work. Answer office from this part of India in sciences now. These are the books we could publish from our research. And this is a thank you for you. So thank you everyone. I think you enjoyed the talk. I think 2-3 minutes before any queries you have. Maybe the young students and scholars in India. And once again, I congratulate the organizers, all the departments, College Authority, and also Pollution Control Board. And you are so lucky today. 2 of the members nominated by Chief Minister. Okay, Chief Minister of Assam, 2 of the members of Pollution Control Board, they are with you now. So me and Dr. Professor Dhrupojuti, Soria, both of us, we are the members of Pollution Control Board nominated by Honorable Chief Minister of Assam. And whenever there is any application for supporting any kind of seminar workshop, when we sit together, we normally study the chairman to pay, give them funds, like that. Are you ready for that? Good, thank you.
So the session is open for discussion. I request our participants and students to keep their questions. So we have many.
I can give you my number also. You can put your question through WhatsApp. I can answer. Okay, 863 83.
I request the students to note down.
86383. Use your mobile, no problem. Use your mobile and put it there. 86383 757. That is my number. I'll take from submission. And I request all of you to use AI to know more. You use AI tools to know. Okay, to know more. Because it is so easy nowadays. If I am to prepare this PPT, normally our honorable professors they know it takes at least 15 days hard work. And nowadays we can do it in 1 week. But that is artificial intelligence. Then you need to use your human intelligence. Then only it will perfect. So therefore we need a professor or a guide, your teacher to help you. Not that you will follow it, but immediately you will discuss with your professor. But go the way. I talk about Pollution Control Board. that both of us nominated by CM and both of us here in this seminar. Pollution control board is a supportive organization and we talk about pollution very often.
So if there is no questions, we can go ahead.
So once again, I thank you Samvita, and thank you all. This took me from home. I said that I should not be late. He said that he assured me. Because I am a person always work, time has come. Thank you.
Thank you very much, sir. Your lecture was really very informative and valuable. It focused all over the community awareness, which is a very important part for the human development, and healthy of good health society can only go forward for a healthy environment in a healthy environment. So this session was really very effective for the seminar. Thank you again, sir. So I request my co-convener, Dr. Madam Kumari Ota, to proceed with the next session. Our next lecture of the plenary session 1 is on digital tools, GIS and AI applications in environmental monitoring by Professor Siddharth Pratim Chakravarti from Department of Mathematics, IIT Guwahati. I request my co-convener to go with a brief paragraph.
Thank you, Sangeeta. It's my pleasure to introduce Professor Siddharth P. Chakrabarty sir. Professor Chakrabarty earned his PhD from the University of Illinois at Chicago, USA, and was a visiting fellow at the Tata Institute of Fundamental Research Center for Applicable Mathematics. Before joining the Indian Institute of Technology, Guwahati, as a faculty member. He has 18 years of teaching and research experience in the areas of financial engineering, computational finance, portfolio theory, and financial risk management, both at undergraduate and postgraduate levels. He has also developed and delivered 2 NPTEL MOOC courses and has supervised 7 PhD theses. He has several papers in the areas of sustainable finance, computational finance, portfolio analysis, and financial risk management in journals of review such as Energy Economics, Asset Business and Economics, Asia Pacific Financial Markets, and Journal of Computational and Applied Mathematics. Professor Chakrabarty served on the editorial boards of 3 international scientific journals and is a recipient of the Reserve Bank of India Faculty Scholarship and is currently a fellow of Institute of Mathematics and Applications in UK. Thank you. Now I invite Professor Chakrabarty sir to come here and deliver his speech. Thank you, sir.
Okay, so it's wonderful to be here. And I want to thank your principal, Professor Sharma, and Dr. Anand Kumar Yoga, who has for inviting me to this event. Uh, Now, as already been told to you, I'm somebody from maths background, but I do a lot of interdisciplinary work, and the genesis of why I'm here today is because I work at the interface of mathematics, finance, and sustainability. So, what I'm going to talk about is a niche area which is known as sustainable finance. And this area pretty much has come up in last 10 years. So it's a very, very new area. Now, I want to motivate. So what I'm going to do is that I'm going to focus on this lecture on two aspects. Right? One aspect is the environmental pollution and its consequences, which has led to the necessity of transitioning to an economy that is more environment friendly. And that brings me to the second question, where we talk about that when I do this transition to a more environment-friendly society, how are you going to pay for it? Where is the funding going to come from? Because this is going to be a massive transition. So first of all, I want to talk about climate change. Now, for those of you who are in my age group, climate change is a reality. And this morning when I was coming from IIT, I was telling my Professor Solanki and Rosa and that Guwahati used to have 8 months of wonderful weather, but that has now reduced. And the fact that we feel the necessity of air emissions a lot more is a clear physical manifestation that the global warming is here. And it is not just sort of scientific discourse in a standalone manner. Now, you see, in the year 2020, the global temperature, if you compare the 2020 average temperature compared to the average temperature between 1981 and 2010, there was a 0.6 degrees centigrade increase globally. And it was more severe in Europe, where the temperature was gone up by 1.6 degrees centigrade. Now, the extreme example of this is in the Arctic and Northern Siberia, the traditionally extremely cold regions of the Earth, where the temperatures were actually 6 degrees higher than the historical average. Right. So now, so basically, what is happening is temperature distribution. That is, if you look at a histogram of temperatures and you look at the distribution, right? How many days it was between 10 to 11 degree, 11 to 12 degree, you will see that this distribution is shifting more towards the right, which means that we are experiencing more days with higher temperature, and we are experiencing heavy days. That first of all, we are experiencing days when there are more temperature, higher temperatures as compared to before, and then such instances or examples of higher temperatures, they are happening more frequently. So it's severity of temperature rise as well as the frequency are both increasing, as is evident in our day-to-day existence. So this is a graph. See, this is a comparison of what is the average temperature between 2020 to 2025, and I compared it between 1951 and 1980. And if you observe something very clearly here, you see that these are the red zones. See, red zones means temperature is risen by that extent. So here if you look at the red zone, that means that there has been about 2 degrees centigrade increase in temperature. Now, if we are on the yellow, brown, and red zone, that means those places have experienced a temperature rise. And if we are on the blue side, that means those regions of the world have experienced a temperature fall. And you see that almost the entire world has experienced severe temperature rise between 2020 and 2025, that 5-year period, as compared to the average between 1951 to 1980, those 20 years. So these are accurate data that were retrieved sometime I reviewed this around July 2025. So this is a clear database manifestation that yes, almost the entire globe is getting affected by this temperature rise. Okay, now, what is the dangerous tipping point? The dangerous tipping point is that you look at the pre-industrial level, right? When the industrial started, what was the average temperature? Compared to that, if the temperature increases by more than 1.5 degrees centigrade, that is a catastrophic level. And the goal is to try and not to let that happen. That means try to make sure that the average temperature rise does not go more than 1.5 degrees centigrade. Now, what are the consequences of this temperature rise? Now, temperature rise has immediate physical manifestation. For example, and the most obvious one are heat and heat wave. You see a lot more heat wave, you see a lot more droughts, and you see flooding in areas which historically has not experienced flooding. So these are clear negative impact of climate change. And why is the climate change happening? Because of emission of greenhouse gas and its equivalent. So now, how do we get around this? So obviously, what is causing the climate change, as I said, it is the emission of carbon dioxide or its equivalent, or the what you call commonly known as greenhouse gas. And in turn, who is emitting greenhouse gas? Industries, vehicles, and so on. So that means if you want to solve the problem of controlling the temperature rise and controlling the climate change, you have to go back to the basic problem, which means that you have to reduce industrial, vehicular, and other equivalent forms of pollution. Now that cannot happen overnight, and that requires massive investment because you need a global technological shift. For example, as you see that nowadays we see a lot more vehicles with green number plates. So those are electric vehicles. Now you see, but still a large number of cars are still running fossil fuel, namely petrol or diesel. So the transition, like you can't expect everybody to immediately buy an electric vehicle because this cost is sensitive. Likewise, you have existing factories which are polluting. Now, if the factory has to adopt a non-polluting technology, that requires a lot of investment. So that means it's a lot of money that is at stake. And where does that funding come from? So now, what is the definition of climate change? So the definition of climate change is something that is given by the IPCC. IPCC is essentially the agency which is called the Intergovernmental Panel on Climate Change, and they have said that it refers to the change in the climate which is visible by looking at changes in the mean of variability of the environment over a large period of time. So that will be a very well-defined definition. Now, this definition in some sense is from a statistical approach, which I will not go into. I want to focus on the environmental part. So, what is IPCC? IPCC was set up in 1988 by the World Meteorological Organization under the United Nations. And what was the responsibility given to them? What was their mandate? Their mandate was to provide policymakers with regular assessment about what is happening to the global climate. And what they do is that from time to time they give this report, and there was the last report came up in during the period 2021 to 2023, and these reports are called AR, alright, which are the assessment reports. So this is the sixth version of the assessment report. And what they have said that the clear human beings are responsible for warming the atmosphere, warming the ocean, and disrupting the global water cycle, disrupting snow and ice, leading to rise in the water level. Sea levels are rising. Now, the main culprit is what is known as, so the main culprit is the greenhouse gas. What is a greenhouse gas? Greenhouse gas is basically a collection of various gases. The primary candidate or member of this club of greenhouse gas is the carbon dioxide. And then there are other ones like methane, nitrous oxide, and hydrofluorocarbons, which is used in refrigeration. So, higher emission of greenhouse gas means increase in concentration, we have more greenhouse gas in the environment, and then this what does this do is that whenever the sun rays come in, it is not able to reflect back from the earth because because the greenhouse gas, higher concentration of greenhouse gas prevents that from happening. So basically the key indicator of how polluted the planet is given by the overall level of carbon dioxide in the atmosphere as a whole. Right? And within the atmosphere is not natural boundaries, which is the atmosphere. So now the question is, we are in a worrying position. And if we keep doing business as usual, that means that we just keep doing whatever we are doing, whatever we do, the consequences. The consequences are going to be, there is going to be liability, there is issue of workability, there is going to be a disruption in the food supply. Like if you have drought in traditionally food beds, what happens? Your food is disrupted, physical assets are going to get disrupted. What is a simple example of that? If I have a house or a building by the seashore, and because of melting ice, the sea level rises, my house can go under the sea. And the first, place which are in danger are the small islands in the ocean, like for example Maldives. There is an apprehension that Maldives may go underwater by 2001. So that region is real. Imagine, that for those people, their country will be gone. If things go on like this, their country will be gone in 75 years from now. Then there's also the natural capital is forests and so on. Now, some of the examples, extreme examples of how the natural capital can be destroyed are the permafrost in the Arctic and the Amazon rainforest in South America. Now, in order to address this problem of pollution, there is something called the Conference of Parties. So basically, it's countries getting together to figure out how to solve the problem. And it started in 1992 with the Earth Summit, which was in school. It was a very big thing, and it was the Earth Summit which happened in Rio de Janeiro, which was in Brazil. And then several rounds of discussion have happened. Another important milestone in this was the Paris Agreement of 2015. So, in the Paris Agreement, what they did was they agreed that every country will set its own targets as to how they are going to control the pollution. And these are known as NDCs, nationally determined contributions. So, India has its NDCs, every country has its NDCs. They have to portray to the world what measures they are going to take in order to mitigate this adverse impact of climate change. Now, so basically the goal is that you not let that the average temperature go beyond 1.5 degrees centigrade above the pre-industrial. And what they are going to do is that, now the question, now comes to my second question. Then in order to achieve this goal, what do I do? So the idea is that the developed countries, or what we call as the global north, which are more, they have more resources, they are going to provide financial assistance, right, to countries which are less endowed, or which is the what is known as the global south. And the rationale behind this is that industrialization first happened in the countries which have more resources. So a significant contribution to pollution happened as things stand now, as a result of heavy industrialization that happened in the so-called developed countries. And hence, it is now their responsibility to help. Now, at the same time, countries which are in the process of industrialized expansion, they cannot be expected to not industrialize, because they also want to have a developing society. So then the question is that so the compromise is that developed countries will have to provide financial assistance to towards setting up environmental friendly technology, while at the same time helping the continuation of the development of those countries which are still in the process of industrialization. And that is where this concept of sustainable finance comes in. Now, this is a global net CO2 emission. See, this is, you must have heard of the word net zero. Net basically zero means that you are polluting and then you are taking some measures to mitigate the pollution. So, your pollution is plus, and then what you are mitigating? is minus. So as long as the difference between these two is positive, that means you are polluting more than you are trying to prevent the pollution. And the goal is to reach a point where this is zero. That means for the amount of pollution that is being caused globally, there must be measures to offset that pollution by an equal amount. And ideally, if it is negative, even better, because you are polluting less than what you are doing to protect the environment. Now, there are very clear, well-defined yardsticks how this can be better. Now, these are four different pathways, which I say P1, P2, P3, and P4. So you can see that P1, P2, P3, P4. So what it says is that this is between year 2010 to 2100. So it is saying that P1 is like business as usual. If you keep doing things as you are doing, then we are going to not achieve what we want. Now this graph is very important because if you watch carefully here, when I say, see, the goal is to have 0 on the y-axis. Now when I have 0 on the y-axis, that means I have achieved net zero. So if I take business as usual, I will achieve net zero only by 2100. But if I take more proactive role and if I start working very hard, and I here means the global community, then it is possible that, for example, in case of P4, you should be able to achieve, to do somewhere in the middle, which is what is not working. So I just showed here. So if you observe something carefully, here this is global, this is net zero. If you take this path, and this path is your P4, and if you take this path, then you will be able to achieve net zero by the year 2050. Yeah, please check. No, the one. Okay. So now, let's move to the next slide. Okay, so now how are we going to fund this, right? The more we fund, the more likely is it that we can achieve the net zero by 2050. And if we don't take enough measure, it will happen by 2100, by which significant more damage has already been done. So the financing happens in the following way. So this is what is the climate finance or sustainable finance structure. So first of all, you have local, national, or transnational financial. So local level could be like the local, environmental agency providing some support, some philosophical organization providing support. National level means at a country level, they make a centralized decision for the entire country to fund. And transnational is the situation where it is expected that the global norm of the so-called developed countries, they are going to support and finance such kind of projects in countries which are in the global south. And then give you the three things is working. So now, and finally, then what happens? Where does the money come from? So the money can be funded by private institutions, projects that government can fund. It can come from philanthropic organizations, like we hear about lots of foundations, like the Bill Foundation or Bill Gates Foundation. They will fund it. And thirdly, through private investors. So what might happen is that if there is a new project for some electric vehicles, then maybe 40% of the investment will come from government, 20% comes from some foundation, and then the remaining 40% that can be raised through private capital. So this is what is known as blended finance, another area we just started about 2-3 years back. And what is the goal of all this? Cash flow from these various sources, and the eventual goal is to support mitigation and adaptation techniques, how to prevent and how to adapt to the new situation. Alright? Prevent means just maybe stop some polluting industry, and adapt means modify the polluting industry into something that is more environmental friendly. That means adoption of new environmental friendly technology. Okay, now let's see who will fund this at a global level. Now there is a mechanism under the aegis of the United Nations. There is something called the Green Climate Fund. Alright? So the Green Climate Fund is something that was created out of the Paris Agreement. And in addition, there is something called the Standing Committee of Finance, which was designed to help this COP. So COP is like the environmental conference for all the regions together. So then what happens? So here, what is the Green Climate Fund? The Green Climate Fund is, there is a board which governs it. It was established by the 194 sovereign nations who are party to the UNFCCC. And this is what they have done. So the GCF, what it does is that, for example, this is the GCF projects last year as of 1st June 2025. These are the number of such projects that DCF has done. So DCF is like a global funding agency which collects money from various sources and then they distribute it to for projects, environmental friendly projects in the global south. So here are some of the numbers. So for example, what they have disbursed is, so far they have disbursed $1.2 billion, which is actually not a very large amount of money, and DCF needs to raise a lot more money in order to accomplish the net zero goals. So these are the number of approved projects, 286. These are spread across 130 countries, and two of the projects have been completed. 246 projects are under implementation, and some of them are just about to start. So this was as of June of 2025. Okay. Now, what I want to look at is, I want to go to the math part of it because my audience is not from the math background. So I want to look at this again. Okay, this is first one, scenario analysis. Right? What is a scenario analysis? Scenario means possibilities. So when I say scenario analysis, what do I think of? See, it is like a day-to-day planning. That if this, these are the things that can happen tomorrow. There are 4 possibilities, and then every possibility I am going to act in a certain manner. So there are different scenarios, and I'm going to do this, right? So it could be something like you have an exam. And you think that if I have 4 days, then I'm going to read the whole book. If I have 3 days, I'm just going to read my notes. If I have 2 days, I'm just going to look at the whole question paper. So basically, under different scenarios, you are planning your strategy. Similarly here, you observe here. See, these are different scenarios. What is this? You see, the line, the red and the blue line that you are seeing, these are the temperature increase compared to the pre-industrial level. Now, depending on how we act from now onwards, my temperature increase as compared to pre-industrial level is going to be different. Now, here what they have is something known as RCP, representative concentration pathways. So it means that if we take enough care, then we should be able to contain the temperature rise to 0.5 degrees centigrade. But if we do not take any care at all and let things go on as it is happening now, then you see this may even go up to 4 degrees centigrade. But you should always take a part of strategy where you can go up to, so this is actually 1.5, you can take this part because you have to achieve that 1.5 degrees centigrade increase maximum that. And any other part is going to get into bigger problem. Because in the worst case scenario, it can even go up to 4 degrees centigrade. So what is this RCP? I'm going to share a little later. So this is also the sea rise level, right? So in the best case scenario, your sea level rise will be 0.4 meter. But in the worst case scenario, your sea level rise can go up to 1 meter. And remember, what is 1 meter? Maybe this one. So if your sea level rises this much, 1 meter. If you have a ground floor house and you have the water coming at that level permanently, then your house is gone. So you can't let that go up to 1 meter. Okay. Now, so these are some of the things I don't want to go into. So I will talk about the representative concentration part. What are those 4 scenarios that I have shown? One of them is RCP 2.6, one is 4.5, one is RCP 6, and one is RCP 8.5. What is the meaning of this RCP? We don't know what is RCP, but what we know is what is ppm, right? When you look at the air quality index, you know what is the parts per million, or ppm of what? The greenhouse gas. So, if we are able to restrict the emissions in between the level of 430 to 480, That is what I identify as RCP 2.6. Now, if I am able to accomplish that the environmental pollution does not go beyond, then what are going to be its consequences? The temperature will be between 1.5 to 1.7 degrees centigrade compared to the pre-industrial level. The probability, what is the chance that it will be more than 1.5 degrees centigrade? That chance is 49%. Well, what is the chance that it will go beyond 2 degrees centigrade? That is 12 to 37%. And it is extremely unlikely that the temperature rise will be more than 4 degrees centigrade is almost negligible, that is 0 to 1%. On the other extreme, if the pollution keeps happening in an uncontrolled manner and the parts per million exceeds 1000, then what happens? Then your temperature typically, whatever temperature will be between 4.1 and 4.8 degrees on an average. That is what is expected. And in that case, your temperature will be more than 4 degrees centigrade. What are the chances that is going to happen? That is between 50 and 78%. So if your parts per million is more than 1000, the consequence of that is that there is more than 50% chance that your temperature increase compared to pre-industrial level across the globe is going to be more than 4 degrees centigrade. So imagine this thing, right? Imagine this, that today if the temperature in Guwahati is 22 and suddenly it goes up to 26, what is going to be the consequence? Maybe not, but in summertime if the temperature is 38 and it goes up to 42, then that impact is significant, right? You may think that you are sitting inside the AC, you are escaping, but no, it infects you in many ways. Food crops, see, whatever food crops are grown in certain region is dependent on the climatic conditions. Climatic conditions that are suitable for that particular crop. If the climatic conditions changes so drastically that the average temperature goes up by 4 degrees centigrade, then the weather may not be suitable for that crop. And that crop production in that region may completely be destroyed. So now, what I want to talk about is, these are some of the. So basically, how does this funding happen? So obviously, that it's all tied to funding. Now, in order to do the funding, so there are two kinds of risks, all right? When you are looking at the environmental, change mitigation, in the context of financing such projects, you have to look at two things. One is the physical transition, and one is the transition of the economy, right? So there is something called physical risk, there is a transition risk. What is the physical risk? Physical risk is sea level rising, droughts happening and so on, something that physical risk, right? And what is the transition risk? The transition risk is that you have to transition from a high carbon economy. And high carbon economy means, we are still using more polluting fossil fuels based, industry and products, and we need to move on to a low carbon economy. And that requires a complete transition in our entire industrial infrastructure. And that means, so it is as if now you are doing that entire industrialization at a global level in a short period of time. So climate finance has become relevant. See, you can prevent that physical risk if you are able to address the transition risk. And when I talk about sustainable finance, it is how we are going to finance that particular transition. Now looking at that, our goal is to have RCP 2.6, right? Because in RCP 2.6, what is happening? If you go back to that table, if we have RCP 2.6, that means so you remember that when I'm looking at that table, RCP 2.6 was the best case scenario where the average temperature is expected to only increase by 1.5 to 1.7, which was what was the goal, more or less, that was set up in the Paris Agreement. Every other scenario goes well beyond the upper limit of 1.5 degrees centigrade that was envisioned in the Paris Agreement. So we cannot so that means all efforts must be made towards achieving this goal of RCP 2.6. Okay, Now, what will happen if I will ask you 8.5? You are very likely to go above 4 degrees centigrade. Sea levels are going to rise. 4 billion people, right? 400 crore people, that is half of the world's population, is going to be at risk of water shortage. And then the surface of the earth will change dramatically. Ice caps are going to melt. And places like this Amazon rainforest, they just die off because it cannot sustain this level of temperature. Occasionally, there might be a good news where places which were not used for cultivation earlier, because it was too cold, because of rising temperature, they may become suitable for agriculture, but those are going to be isolated cases. The damage is going to be far more than isolated cases of positive outcome. Okay, so the IPCC ARC focuses on this sustainability. So they basically look at shared socio-economic pathways. Shared means collective, human beings share socio-economic pathways, societal economic pathways. If we take the SSP1, we are going towards sustainability, which is like RCP 2.6. And if we are going on growth focus, that means we keep growing in the way we scenario, then it's the worst case. You have to have this RCP 8.5, and that is the essential. So basically, this SSP5 is the path that we are following currently, where we are still heavily reliant on fossil fuel based concept. But what we should aim for is the pathway which moves towards sustainability, namely SSP1. So these are very well defined. If you go back and look at the IPCC report AR6, these are the things that, and in order to assess all this risk, we have something known as an integrated assessment model, which incorporates both transition risk as well as physical risk. Okay, now I just want to, I'm almost done. So I just want to make two observations. When I was talking about sustainable finance, I essentially focused about how we are going to fund these things, and I said that okay, there is this green climate fund which is there. What they do is that they essentially land with something called the blended finance structure, where the government is first going to put in some money. Then they are going to get philanthropic organizations to support, and then they are going to get private investors. Now, in order to attract private investors, what they do is that, see, this is at the end of the day, this will be some industrial project which will generate profits. So when the profit comes, they tell the government, tells the private sector, look, we are putting in the initial amount of money, you support us, but when the return starts coming, right, from those industrial projects, those environmental friendly projects, we are going to give you the first share of the profit. And that is the model that is being adopted because government or sovereign nations cannot fund these things entirely. They have to involve philanthropic organizations and they have to involve the private sector also. Another aspect of sustainable finance is from the point of view of investors. See, if I am an investor who is investing in mutual fund, I am going to look at whether the mutual fund is investing in sustainable assets. Because what might happen is that if I invest in, say, a stock that is heavily reliant on polluting technology, then there is a risk that after some time the government will bring in a regulation and that industry goes out of business. Then what happens to my share? My share becomes worthless. So, increasingly, there is a pressure from the side of investors on fund managers who are in turn putting pressure on companies to invest more in sustainable projects. And so, in an indirect manner, investor preferences for sustainable investment is indirectly pushing the private sector to go and invest in sustainable projects after the government has made the initial investment. So this is a summary of the overall structure of sustainable finance. And I now want to end with this last slide. What we basically said that I want to make only 2 points. First point is that you see, it's easy to do blame game, like one country blaming the other is, but at the end of the day, we cannot look at pollution that you are polluting more, that country is polluting more, this is the per capita pollution. Because when the negative impact happens, it is a consequence of the sum total of the entire greenhouse gas that is permeated our atmosphere. And hence, in the words of Greta Thunberg, the house is on fire. And while nobody is fighting the fire at a global scale, there are some tools to manage fire in some of the rooms. So think of this as that the entire globe as a house is on fire, and by fire I mean that it is impacted by climate change, and we have to put out that fire as a whole. Right now we are doing it isolated and putting out the fire in individual rooms, but that does not solve the problem. You have to put the fire out in the entire house. So the climate change and its consequence, the climate change may have been caused by certain nations, certain actions, but the impact is uniform for everybody living on this planet. So I just want to conclude by, so these are some of the references I used. If you're interested in looking more on climate, sustainable finance, I suggest that you look at the IPCC report, the assessment report, 5 and 6, and also you please look at the website of the Green Climate Fund. Okay, so thank you all for your patient hearing, and I'd be happy to answer any questions somebody might have. So I have just requested the audiences, if anyone is interested, please share the slide with them.
Okay, sir. Thank you very much, sir. The session is open for discussion now. The participants as well as the students may ask their questions. Yes, sir.
Oh, you have a question, please.
Okay,
Please give the mic to
so
sir.
that everybody can hear.
Yes.
Actually, my question is related to electric vehicle.
Yes.
First one, what is the future? Will it be available in future for all, or there will be limitations?
I think it is going to take quite a bit of time for electric vehicles to be available for everyone, unless there is a heavy investment in order to produce electric vehicles at a faster pace.
Okay.
See, the number of petrol or diesel vehicles that are running on the roads, they must have been bought over last 15-20 years. So obviously we cannot expect that we can replace all the electric vehicles in a matter of 2-3 years. There are two things. One is the affordability aspect, and the second is whether the supply chain can supply enough vehicles.
Okay.
So it's very interesting he asked me
Yeah.
that.
So
So for those of you who
Yeah.
don't know, the original vehicles that Ford had made, they were actually electric vehicles.
Yeah.
It just started, and they suddenly moved to petroleum, and now they have to go back to electric vehicles. Yes.
So another point I wanted to, it will be a suggestion from you for the learners that according all 17 SDG goals,
Yeah.
on which Assam, especially Northeast, should take strong action.
Oh, that is, I think the main thing is primarily one thing that is to be done is ensuring that the natural resources, flora and fauna of the region, this region is very diverse, very rich in flora and fauna, that has to be preserved. I think that is one goal that has to be particularly emphasized.
Yeah, that is a great message going to our learners, youngsters.
So that's why this is a lot of times I encourage people to study environmental science, because that is the future. Any other questions? Our young participants, they are very shy of asking questions.
Well, you got a question before that. It's a great opportunity all of you are getting.
You see, asking questions is your right.
We have students from College University and Guwahati University also. I request them to ask any questions.
It's okay, they can ask me over lunch if they are feeling shy now.
Okay, thank you, sir.
Okay, thank you so much for this, and thanks to the organizers and Assam Pollution Control Board also for taking the initiative. And it's wonderful to see that they have recognized the importance of this kind of discourse. Thank you again.
Thank you very much, sir, for this informative and interesting presentation. And it is, I hopefully think that this topic of sustainable finance is going to have a good impact in the sustainable development of the overall human well-being. Thank you very much, sir. Moving forward to our next plenary lecture on water, air, and soil quality management challenges and innovatives by Professor Subhajyoti Sohoria sir from Department of Geography, Guwahati University. Briefing his introduction, Professor Subhajyoti Sohoria is a distinguished academic and research serving as professor and head of the Department of Geography, Guwahati University. He holds his master's, MPhil, and PhD degrees in geography from Guwahati University, with his doctoral research focusing on wetland and floodplain geomorphology in the Brahmaputra floodplain. His areas of expertise include fluvial geomorphology, floodplain dynamics, land use change, and geospatial technologies such as GIS and remote sensing. Professor Sahoria has more than 2 decades of teaching and research experience and has published over 60 research publications in reputable national and international journals and edited volumes covering themes such as reverse systems, land use change, environmental vulnerability, and climate change impacts. His scholarly work is widely accessible and frequently cited, reflecting his strong contribution to environmental geography and geospatial studies. He has also been actively involved in significant research projects funded by agencies such as ISRO and the Department of Science and Technology, Government of India, including studies on sediment dynamics, climate change impacts on eastern Himalayan ecosystems, and the application of geospatial tools for natural resource assessment. Professor Sahoria has successfully supervised several PhD and MPhil scholars fulfilling academic research in natural resource management, environmental change, and geospatial applications. His distinguished contributions have been recognized with the Best Geography Teacher Award 2023 from the Indian Geographical Society of India. We are honored to have you here, sir. Over to you, sir.
Okay, thank you very much. So, there is a slight change in the title as I had proposed. So, I talked about sustainability of land and watersheds of Northeast India. In fact, whatever I'm going to present, these are part of some of my publications. We have published in some of the leading journals. And if you want more details on these publications, you can go to the publications. But otherwise, I will show you links on me and my students who visited in different parts of Northeast India, and based on our direct field experience, I am going to show few of the information and some of the secondary information I have gathered from Indian Meteorological Organization. So if we start with Northeast India, okay, so if you see the map, this is very rugged topography. And compared to the other parts of India, and this region is one of the most crucial parts, not only from the geography, biodiversity, hydrology, then climatology, then other cultural linkages, not only this, but the other cultural linkages that we have in the Southeast Asia. So we are in between, not only for the physical and biological science, but also for the cultural activities. We are in bridging point between different parts of the world. And if you see this basin, Brahmaputra basin, the whole region is crisscrossed by numerous tributaries of the river, and these rivers especially have very impact on. I believe that all of us, especially the students, you have grown up in villages. Okay, so we know our village life is accustomed with rivers. Okay, and every village has something to relate with a river, and these rivers as well as the water bodies have very distinct place in our northeastern lifestyle. So region is a now if we see that this region is in a type of crisis. Okay, so what we are restored with very much, we are very healthy resource from in terms of land resources as well as the water resources. But the way the things are happening, as or my previous speakers have already said, with some examples from both from the global scenario as well as from the local scenario, that we are experiencing certain changes in our day-to-day life, and that has created tremendous pressure on the our landforms. So if we have a general idea, or we can see that this is the Brahmaputra Valley. What is the Brahmaputra Valley? The main lifeline of our region. We have almost 50% of Brahmaputra Valley falls in China. Then we have India 33% share of the Brahmaputra Valley, Bangladesh 8%, and Bhutan is in 7%. And then if we talk about the drainage area percentage, in Assam is 36% of the Brahmaputra Valley. So these constitute the whole the environment of the region. Then if we see the profile of the Brahmaputra, then if we draw the longitudinal profile of the Brahmaputra, you can see that it is from China, especially in when it enters in India. P point, from P point, there is a sharp decline of the altitude, and this sharp decline has created tremendous force, especially in the three-road dam. You know that there is a syntaxial band in the upper part of the northeastern corner of the northeast India, and that band has a sharp decline, and especially from Pasighat to Pangu or Diburi, we have a very plain area. The slope is very low. And if we talk about the water resource potential of Northeast India, then we have 20% more times of water per capita water than the national average. অর্থাৎ ভারতবর্ষের প্রতিজন মানুষের যিমানখিনি পানি পায় তাতকৈ আমাৰ 20% বেছি 20 times বেছি আমাৰ পানী আমাৰ মানুহে পায় but whether we are able to use that thing. So 30% of country's total water resources falls in Northeast India. We have hydropower potential is 41%, but we are using only 3%. We have irrigation potential of 4.26 million hectare, but we are using only 0.85 million hectare. So that means, despite the tremendous water potential, we are having a very low use of these water resources. But at the same time, whatever water resources we are having, we are now creating some kind of crisis point. So this region is very much characterized by its biodiversity, endemic species, diverse ecosystem, and then you see the elevation. Then so you see that majority of the part, first, second, and third row. This is the point 50 to 100 or first 10 to 50. This is the major of the slope. Okay. So the whole part, especially in the Assam Valley, falls in this very low slope region. Therefore, the flow of water is very low. And this is the elevation map, and especially the lower Brahmaputra part. This is the low slope region, and this is
the rainfall, distribution of rainfall. Now, thing is that we have a very high rainfall. Generally, from our side here in our classroom, we are taught that we have very high rainfall, especially in Serampore. This is very not well distributed. Okay, so we have the experience of very high rainfall, but we have very experience of very low rainfall in some regions. We have very high rainfall in July and September, very low rainfall in January and February. So this distribution is not same. But at the same time, during the last few years, this distribution has been very much erratic in nature. That, for example, if you see the graph, this graph shows that extreme events, the large excess events are increasing in especially in Assam. Then these are the certain statistics which will show you that in our region, this number of extreme event response are increasing. Then this is the from last January 1 to the yesterday. Next January for Guwahati level with our sum per day event. Then we see that all over the northeast we have a very scanty rainfall, no rainfall level, very large deficit month. This is the large deficit month we are experiencing. Then where many districts except few, okay, these districts are facing very moderate to high amount of drop in rainfall. These are the very recent data. Then we have a heavy rainfall events in the pre-monsoon event. If you see the rainfall event, the pre-monsoon means March, April, May. So in this period, you see that we are having a very high rainfall events increasing. Then during monsoon also we are facing that from normal to high to extreme events. Then so these are different maps, and if you see the over the period of time, so this distribution is not homogeneous. From normal graph, we are having actual rainfall is we are having much more rainfall in this region, and not only that, these rainfall events are very erratic in nature, and extreme events are more. Then similarly, if we talk about the flood events, all the major districts of the Brahmaputra Valley they are experiencing flood. Okay, so now based on this problem, for example, water availability is a resource for us, but at the same time, the same water availability becomes a problem for us. Now, with the help of the other changes we are experiencing, for example, Professor Bhuttaji has already said that there are different global warming scenarios we have experienced, but based on that, it has certain local impacts. These global changes have certain local impacts in our region. What are they? If we so we have certain land management challenges as well as certain water management challenges. So based on this, for example, I'm not going to discuss all the challenges, but some of the I will give just few examples. Like for example, intense rainfall, for this rainfall and for agricultural practices, the land is further degraded. That is one reason. Then the acidity of soil will be increased over time. Then the flood has been increasing more overwhelming sediments, especially all the major river districts are putting sediments. I have few slides to show or as an example. And then also similarly we have water river bank erosion. Then we have flood recurrence flood events. So these challenges have, and then also the drying of mountain springs. Many of our communities are still dependent on mountain springs for their daily water, but these springs are reducing day by day. So it has created and the other issues like dams, mega dams are there. So based on all these things, if we talk about if we summarize the environment of Northeast India, then it characterized by forested and protected areas, river network. Then we have more than 3,500 wetlands in the Brahmaputra basin. the traditional knowledge system as well as the hygienic lifestyle. But with age, we have also experienced certain amount of degradation. This degradation is that this deforestation is manifested by deforestation of our resources, then extreme events, stress livelihood, bank erosion, then climate uncertainties and crop failure. These are the certain evidences of degradation we have. Then if we see that overall how our land resources have changed over time. In 1973, there was 51.17% of vegetation was there in Northeast, but which is reduced in 2021 from 51 to only 41%. So 10% reduction of vegetation. And then water bodies, we have 9.21 we have 4.87. Then built-up area 2.86, it increased to 13.86. So there are certain evidences that human beings are creating some kind of pressure on our available land and water resources. This is the example of our one of Gangotri glacier. Okay, our students, you can see that we have supported by this type of our whole rivers. Rivers actually we get water from the glaciers, but these glaciers are retreating from time to time. These are at different points of time we have taken satellite images, and we see that these glaciers are retreating, and therefore the retreating glaciers cannot provide enough water to the one, and that is one, and some point of time this melting glacier also contribute to more water in certain point of time. That means creating discharge level will experience in the river. Similarly, these are the conditions of law. The sudden landslide created in the high, especially in the upper states, it created dams. This type of dams have been created by the landslide, and by breaking of this landslide, it created a tremendous flood in the lower Brahmaputra Valley. This is the in 2004. If anybody remember that in 2004 Assam experienced, especially lower Assam experienced a tremendous flood. This was created by this type of landslide in the Bhutan. Kurusio, Manav story before to our Assam. So there was a temporary dam created, and by the breaking of this dam, we have experienced tremendous kind of things. Now. From these things, what we have found that there are kind of lot of hydrological uncertainties we have experienced. That is rainfall variation, total precipitation, and regional differences are there. These are future climate scenarios, which is these are the prediction of climate we have model. Then we see that this Subansiri River, this is the model for Subansiri River. The Subansiri River is moving towards west. Almost 20 kilometers is without notice of the surrounding region actually. So last 100 years time, the river has been moving towards west, and there has been tremendous amount of change. And similarly, if we talk about the Majuli Island, this is another study of the Majuli Island, where we said that amount of the river has two different, one is aggradation work and another is degradation, erosion and deposition. So now, in course of time, the erosion work around the Majuli has been increasing and deposition has been reducing. Therefore, we see the balance. The erosion rate is hard erosion and greener deposition. The compared to erosion, deposition is less. Therefore, the amount of Majuli, which was once 1200 square kilometer, now reduced to only 400 square kilometer. Similarly, riverbank erosion and sedimentation, these are the certain evidences. And then flood susceptibility index, based on the satellite images, you see that where the most prominence of the flood is has been increasing day by day. And then see that very high, almost 30% and 17%, over 47% of the total area of state are susceptible to very high flood. These are the Brahmaputra erosion, bank erosion of the Brahmaputra in different parts, and these studies show that we are experiencing very high bank erosion in different parts of the Brahmaputra. Similarly, the land use change in the buffer zone of Brahmaputra River, there has been tremendous change. If we from 73 to 2021, if we see the changes of the land use in the Brahmaputra basin, then we see that built-up areas are increasing day by day, and these built-up areas have tremendous pressure on the forest resources. And you can definitely see that greenery, the greenness of the region has been reduced considerably over time. And these are the predicted scenario of the scene. So for example, predicted for 2030, 40 and 2050. These are the different how the built-up areas are being increased and the greenness is being reduced. Similarly, the status of vegetation index over time it has been reduced considerably, and these are proved by the and this is another study on the Kaziranga Cardiac interface region, and if you see that this land use land cover of the Kaziranga over the last 1990 to 2020, and this has when we see that the predicted land use of this region. We can't find that there is a tremendous change, and especially in the future scenario through 2050, and there will be fast change in this region. And we know that Kaziranga is one of the main attraction of the region, not only for the tourist point of view, but for from the biodiversity point of view, for the conservation point of view. This has tremendous impact or tremendous. By 2020, we see that there are increased fast frequency and intensity will be in this region. Since the biodiversity pattern, agricultural vulnerability, and impact on river system, and this has been shown in this model. So, impact on ecology of Kaziranga National Park will be very high by the end of 2050. Similarly, we have another study on Tulsi River. Tulsi is a very important part in the southern Assam, and we had especially the habitat of river dolphin. Okay, and now see that kind of water level in the last few years, it has been river in this decreasing trend. Then monsoon season as well as the post-monsoon season showing decreasing trend. Mean water level showing decreasing trend. Then water is discharge and pre-monsoon. These are also overall not showing very good trend. So that means that this whole region is facing shortage of water, especially in the Tulsi basin. This is the photograph of Jiadol basin, Jiadol river, and you can imagine that this is one photograph with one day. Within the 300 period of 3 hours period of time when we visited that river in the upstream, more than 100 rafts like this comes in 3 hours time. Okay, so that means you can imagine in a season or 30 days time or 60 days time, what is the amount of logs is being carried away by this river, and then you can imagine the amount of deforestation is being held in the upstream of Jiadol, and the impact of this deforestation in Jiadol, you can see a link with the other impact. This is the example, but when we try to validate this with the satellite data, then we see that there has been tremendous vegetation along with this the total landscape times this data. Then these are the temperature. Then rainfall erosivity index. This is the especially this in the Jiadol basin and western part of the Himachal district. This is the Jiadol basin, and you can see that rainfall erosivity index is very high. Precipitation concentration index is high. And then we have tried to put a model, soil water assessment tool model, and this we have calculated on surface runoff or total amount of sediment in this basin, and it shows a very high amount of sediment load is coming from this river. Now these are the examples. You see the deforestation in the upstream, and suddenly the sedimentation from the river comes, and the whole paddy fields. This was once paddy field, now it's converted to a sandy desert. Okay, those people, Dhemaji was once known as the rice bowl of Assam, but now they are cultivating pineapple in the paddy fields because they cannot grow paddy. So these are the consequences we have. This is the scenario. For example, this is kitchen garden where we have sedimentation. This is the Lamori LP school. Now we can see that, and then living missing village where everything is now sandy. Now this is the proof. This is once a RCC roof. It was totally buried under sand, and we have to build another house over it. So this is the amount of sedimentation in that particular village. And then see, we have highest amount of rainfall, but at the same time, we have people who do not have enough drinking water. Okay, this is they have to dig this kind of wells in the river bed and to get drinking water. So that means this kind of inequality, despite being so much of water availability, we have 20 times more water availability, but at the same time we don't have enough water to drink. These are the situation, and our researchers, I request our young scholars or young researchers to look into this matter. And then this is the examples of Haflong railway station. Okay, so until and unless we make a balance between our development and environmental concerns, so we get this type of things in the days to come. Then we have these are the bank erosions. You can go. I will give you more examples from local. For example, we have wetlands. Coming to wetlands, these are the. This is one study done by 1992 by RSET, where it has found that 3,513 wetlands are there. But few years ago, in just 3-4 years ago, I just checked whether these are actually. Statistically, everybody is saying that we are having these months of wetlands in Brahmaputra. But actually, when you have that wetlands, then majority of these are the certain examples. All wetlands are already converted to agricultural field. Many wetlands are already gone to rivers. So they, although statistically people are saying that we have these wetlands, but actually in the field we don't have these wetlands. These are already gone. Only out of the 89 wetlands, which are more than 100 hectares, as per the 93 census, we found that only 12 wetlands have at least 80% of this quality intact. We found that some of the very good wetlands in Assam now is that Govangibit, Samaranga, then Borsola, Haribanga, Thiribit. These are certain examples. And then we all know that this present age is also on a wetland. Okay, so this is the Zola wetland, and we have. So we need to decide, and we cannot think that conservation, development, so therefore the advocacy, environmental advocacy is one of the important factors, because until and unless our decision maker takes care of these points, then so this kind of seminars will not be a fruitful one. So I will skip this. These are very, especially in the wetlands, these are biodiversity there. I will not discuss them. Or cultural things are also related to this. Then coming to Guwahati. Okay, Guwahati will be generally, especially in the surface depression. In geologic surface depression is part, then we say that water cannot move out of that part by normal. Okay, so if water comes to this region, normally water cannot go out of that region. But this is the Nabinagar area. And now, so flood vulnerability, we talk about flood vulnerability, this region is showing very high vulnerability and impact. And we have all the outlets. This is the Silsako Field. Okay, Silsako Field once. The major outlet of water, stormwater outlet for the eastern part of the from before the Hasra with Narangiri, Gonda, and Hasra. But now it is transformed to a simple drain. Then these wetlands, we have the concern of getting a clog in the wetlands, and we are occupying the workplace, and so in that case, we are having the flex plug in the region. This is the model rule in Sabipur region, the outlet of Warsaw. Okay. So you can see by just not do any scientific analysis, just see by seeing the example, you can see that how polluted this is. So this kind of and this will finally go to the Brahmaputra river. Okay. So this actually whole region, the base of this land and water resources, we are getting the ecosystem services. Okay, whatever resource our people they are getting those ecosystem services, and we try to see that how these ecosystem services are changed in Northeast India, and then. Generally, this ecosystem studies coefficient is given by Costanza in 2014, and within the same methodology of calculation, we try to see that how landscape Northeast India 2001 to 20, and then we found that the ecosystem values are significantly are changing in this northeastern part, and this is another area of research in days to come. So we need to now think that collaborative research is needed. Sometimes whatever we are experiencing in Northeast India, it's single discipline cannot decide or cannot work on the whole because it's a very complex issue. So from the scientific understanding to have a better scientific understanding, multidisciplinary approach is needed. Regional and international collaboration is also very important. Then coping mechanism. So how this, as I have already mentioned, that those who are trading cultivators now they are cultivating pineapples. So these are nothing but the coping mechanism because we need to move on, and to move on, what are the different coping mechanisms we have? We need to see. This is the picture of Paro Bhutan, and I am putting this picture only because that Bhutan is a very our nearest country and one of the very good example of how nature and development go hand in hand. We should not go to anywhere in the world to learn sustainable development. Probably we can learn many things from Bhutan and how they are doing. And then if we can replicate their understanding in our region, then probably we can achieve many things in the days to come. So we have a very enough resources in our locality, but point is that these resources we need to learn to how to manage, and then there are certain green financing already. So there are certain opportunities for which we can aid our natural resource management approach, and these are the certain approaches already we have. And thank you very much. Okay, so I try to half an hour. So I believe I can manage with the time. Thank you.
So the session is open for discussion. Participants may ask.
Any mobile lesson, mobile mic.
Yes.
Mobile mic.
It's okay. It's available.
Copying nothing serious. They need to hear because they are our future. Very nice presentation. More communication issue. Excellent presentation. One from Professor Chakraborty, another from me. So if you do not ask question, then think yourself, why are you attending the seminar? Ask this question to yourself. Because very often we talk that you are the future. That is the student. You will be one, but you may be extraordinary. So therefore, my point is that it's a very good example. You talk about Bhutan also. We have been to Bhutan many times. Happiest method in the world. Okay? No carbon emission world. So therefore, I think that is very good example for our students. My point is that what is the future which we should refers to water, okay? In a city like Guwahati, so many now, okay, people in lakhs and lakhs now live, okay? So what is the future? Many a time we hear that mainly the Vishnu part or the Sanmari area will not be getting water when there are multi-story skyscrapers. So like that, I want to know from you the future.
Okay, Guwahati, we are having almost 15 million population, and we have Guwahati population is more than many countries of total population. Okay, so many are foreign visitors. When they come to this part, they rarely see that such a big population in a small area. But so until and unless, as I mentioned, we have almost deteriorated the drainage system of the Guwahati. That is one point. And we have two major channels. One is towards the eastern side, another western side for Diporville, Khanagan. This so Diporville, if you recently visited the Diporville area, you can see the development that is taking place. And I don't see that we have a very big future to the Diporville because so this we need to take a very strong uh, uh, social change, social belongingness by the citizens or by the students. Then until and unless we do ourselves, it will not going to change because the amount of now the way these floods are coming up, the amount of the groundwater extraction is very high. So therefore, some other green practices like rainwater harvesting or whatever measures, structural measures we are applying, especially drainage and other things, I think they are not adequate to deal with the problems. That is the many times these are stopgap arrangements. We don't have any holistic planning for the whole the city. And but of late there are certain areas where we are seeing these things. I believe that there should be a concerted effort both from the government, academic institution, as well as the public or non-governmental organizations. Then only we see the future of Guwahati will exist.
Thank you. So a clap for Professor Subulia. So my second point is that so as an academician, you are the head of the department also. When we visit other countries, we are so happy that they are doing so good. So as an academician, what we can do in constructing our syllabi? Because suppose my department is geology, your department is geography. So when we talk about like what Professor Chakraborty presented and many others presented, so we need to do something. That is one suggestion from me also, that we need to talk to the professors who are making the policies in colleges which are not autonomous. So the university department said that even if it is autonomous also, we are invited as academic advisor or member of the academic council. So my request to the young energetic faculty members, so that you can connect professor and talk about that type of thing which we need to be successful in solving problems. Not just that we will be taking some courses or papers with content of syllabi that which may not have any impact. So that we can do. Because in one workshop I was attending, one professor asked to the audience, participant, that how can you formulate your POs, program outcomes? And when you make a course, how can you make the course outcome? Then the participant reply was, one immediately replied, that's why we make the syllabus, then we talk about course outcome. Just opposite. We need to think about the program. We are offering a program like environmental science or that master degree in environmental science. And in there, we need to think that what should be the content. First, the problem outcome. We have a problem, what is the outcome? Then that may help in future. And also we have a course. Then we need to think about the course outcome. Then you connect the content. That which content we need to put into this course. Course means the papers. So therefore I am telling you that we need to be careful. The faculty members, especially in colleges, which are autonomous. And also, what university will guide for the affiliated university will guide for other colleges. So therefore, those are so also dynamic university. Okay, he is one of the dynamic professor, especially IQSC. He is holding the side of IQSC that is very dynamic today because of his hard work. Not to talk about so many responsibilities like NIRF. We need to show up ourselves. Why we should be lagging behind? We have been looking after NIRF also. So NIRF ranking, so all should be very careful about those things. Then students will come forward to help us. So thank you, over to you, Kanam. You are the person, right from last 1 month, connecting me. Sir, you should be there. I said, why not? I should go there. Because I am in the whole process of development of this college. Thank you.
Sir. Thank you very much, sir. It was really very interactive and interesting topic for the seminar and for the students and everyone here Hago. Land use, land pattern study is very much important for look after what is changing in our environment, which is again have a big impact due to the climate changes and urbanization. So this is in fact again causing different problems. Even in Haglo, we face different problems of flood because of the unplanned or urbanization which is coming up to date. So this is going to be very helpful. There is a lot of scope of research in and around Haglo because of the degradation of the wetlands. So we request her to help us for future research in this scope and I also thank him for his presence and beautiful presentation. Moving forward to our next and last plenary session on green nanotechnology and sustainability by Dr. Kulokamal Senapati, Senior Technical Officer from IIT Guwahati. Briefing his introduction, Dr. Kulokamal Senapati is an Indian chemist and scientific professional recognized for his contributions to chemical science, analytical expertise and research. He began his professional career as a scientific officer at the Indian Institute of Technology, Guwahati, and currently serves as a senior technical officer in the Department of Chemistry at the same institute, where he oversees sophisticated analytical instruments and supports laboratory operations for undergraduate and postgraduate programs. He has conducted extensive research in materials, catalysts, green chemistry, bioactive compounds, and material chemistry during his PhD and subsequent research career, contributing to collaborative studies and scholarly publications in the field of chemistry with over 1,400 citations and an H index of 70. Earlier in his career, Dr. Senapati worked as a scientist in the Department of Biochemistry at the Toklai Tea Research Institute, where his research focused on tea biochemistry, including the analysis of bioactive compounds, diversification of tea byproducts, and value addition in tea. His work significantly contributed to the scientific understanding of tea chemistry and its biotechnological applications. In recognition of his research excellence, he received the National Green Innovation Award for understanding contributions to green chemistry and cleaner chemical technologies, and one of his research work was featured in Nature India, reflecting notable national level scientific recognitions. He also had many publication books which is authored by him, and the sixth sense further reflecting his commitment to knowledge, dissemination, and personal growth. It is our honor to invite Sir and to kindly deliver your lecture. Over to you, sir.
Thank you, ma'am, for your kind introduction. Respected principal of this college, respected dignitaries, respected Ruben Kolita sir, Professor of Guwahati University, respected Rubodri Soria of Guwahati University, and respected Chakraborty sir of IIT Guwahati. Yeah, it is my pleasure to give a lecture on this topic, green nanotechnology and sustainability. In fact, this is a field where you see this cutting edge research means its responsibility towards our nation as well as our future generation. So our future generation does not belong to human beings, so it belongs to other creatures as well. So if you can philosophically, if we say, so it gives us the possibilities of being a human, not only just human beings. So towards coming to nanotechnology, yes, obviously it gives us a tremendous power. So at the smallest possible scale. So in this possible scale, with this power, you see this green nanotechnology. So it makes us the possibility how wisely, safely, and sustainably we can use this nanotechnology, its power, and how we can realize. But yeah, if you want to, before going to nanotechnology, you see the idea of nanotechnology actually came before long back, before its scientific, real scientific outcome took place. Alright, so it was in 1959. So a very renowned scientist. His name was NSESAS-2026 I. So he gave a visionary lecture at the California Institute of Technology. So his lectures was entitled "There is a Tragedy of Room and the Bottom," an innovation to entire field of physics. So during that time, he imagined actually in the smallest possible scale. So atom or molecule by molecule. So material can be designed and developed. Alright. So, but that time what happened? Because that time there was no such tool, and that's why it sounded to be quite impossible to work with this very smallest possible scale. Alright. So for the first time, the word nanotechnology was used by a Japanese scientist. His name was Norio Tomiguchi. So while he was working at the response. Okay. But till 1980, so there were no such tool to measure the smallest possible scale to get the nanoparticle to study the nanoscale device. So it was in 1980 scaling tunneling microscope and atomic force microscope came into existence. So in 1981, the scaling tunneling microscope got Nobel Prize. So from during that time, so this nanotechnology study field has been widely used in different fields. Alright. And in 1990, you see the discovery of C60 or polarity is an avogadro of carbon, and then quantum dots, and then carbon nanotube. So he revolutionized the entire field of the nanotechnology. Okay. Yeah. So basically, my lecture will be in two parts. Actually, this is a fast field. Within a very 30 minutes or 40 minutes, quite difficult to cover up. But I will show this most significant point to highlight some point about the significant process of nanomaterials as well as its characterization technique
and some application in green nanotechnology in sustainable development. I am not comfortable with this. Anyway. Yes, if you see the nanotechnology, now in every sector nanotechnology we have been realized. So in every day we have been realized it is a fundamental element. Without matter we cannot live on. Okay. So how matter prosper? So it makes our life better. So this nanotechnology, it is a part of material science or matter. So it has a huge potential. So it has unique features, it has unique properties and useful applications. But what nanotechnology actually, in my part, I entered in nanotechnology in 2005. Alright. While I joined the Indian Institute of Technology as a scientific officer at the Central Instrument Facility, very particularly and all sophisticated analytical facilities were there. So my first introduction with this scanning electron microscopy. So that was the fundamental thing to get the morphology of the nanomaterial. Whatever is synthesized, you can see. So without seeing, you cannot believe. Alright. So now it was, see, from 1960 onwards, during that period, 1960 to say 2000, so there was no such advancement in nanotechnology. But from 2000 onwards, it has been tremendous development in every sector. But now, this time, actually you see it is a artificial intelligence time and machine learning, or whether it can be say robotics. So this has been popularized, and earlier during that time when we started that work or before 10 years back, so everyone put the words nano in their work. So that was a buzzword that time. Yes. So that time, so that was a reasonable when you want something and then use the term nano. But now this is the time we do not use the nano, but we do not even we do not measure. So measurement is redundant. So we do not use, but in every sector, everything is quite integrated to our day-to-day life. In every sector, technology is there. Alright. Basically, what is nanotechnology? So what we are doing in the smallest scale, 1 to 100 nanometer, so it is the nanotechnology. So you can manipulate the things at the nanoscale level. Roughly say in 1 dimension, 2 dimension, or 3 dimension, maybe 1 to 100 nanometer. Alright. So this at the very smallest scale, so it has a tremendous power. So it has unique property. It is completely different property from the bulk material, bulk counterparts. Alright. So it has, due to quantum confinement effect, or whether it can be high surface to volume ratio, or whether it can be extra stability, mechanical, thermal, or whatever. So green nanotechnology, particularly if you see, it actually encompasses the nanotechnology as well as the green chemistry principle. Green chemistry. So green chemistry, what does it do? So it is the atom economy, atomicity, or you can say is reusability, low toxicity, or less toxic byproduct, or maybe avoid this stoichiometric reaction, or you can have, you can say this recyclability. So all these things are the basic principle of green chemistry, and green nanotechnology encompasses the nanotechnology as well as green chemistry principles. So green chemistry principle actually it was in 1989 a very renowned scientist, two very renowned scientists, Warner and Matisse. So they postulated 12 principles. So it is widely adopted by worldwide. Alright. So now green nanotechnology has been applied in every energy sector, whether it can be energy consumption, whether it can be energy storage, whether it can be energy transmission, or whether it can be in energy or other energy conversion processes. Yeah, if you realize, actually if you see, nanometer is very small. So our human hair, you can see, is a 50,000 nanometer, one human hair size. So you can imagine how small. So maybe in gold atom, if you align one by one, 3 gold atom can give you a 1 nanometer scale. And 10 hydrogen atom give you the 1 nanometer scale. So is this extremely small. And people put on measure because nowadays for this scanning electron microscopy or atomic force microscopy, you can manipulate, you can design and develop atom by atom. So nanolithography is another very significant thing in this area. So we can have, if you see in scale, so 1 to 100 millimeter, there are so many naturally occurring nanometers as well as there are synthesized or prepared nanometers are there. So maybe liquid nanoparticles, gold nanoparticles, polymer nanoparticles, or toluene what I have already told, or ZIF. It is a see, it is still nanotechnology in very recent years, within this decade, you can say, so many Nobel recognized work have been linked to the nanotechnology as well as to the environmental science. So one such work is ZOF, MOF, sorry, metal organic framework. It is last year it got the Nobel Prize in that area. Another is very highly in every electronic sector it has been working with, that is the quantum dot. So in 2023 it got Nobel Prize in that area. Or it was started in 2016, if you see the molecular basics. So now it is basic things of this this robotic technology. So many things in this area have been well recognized, Nobel recognized as well, which is linked to the environmental science, nanotechnology, and nanotechnology. So yeah. So once you come to this small size, so it definitely gets tremendous energy. So with this energy, you can have this transformative power to send so many things, design so many devices. Right. Yeah. If you go to physics, so properties are same. So what properties are same? If you see up to 20 centuries, if you look at the up to 20 centuries, all motions, molecular motions, microscopic motions, or macroscopic motions, Newtonian mechanics were dominating. Basically, Newtonian mechanics, whether maybe is in trajectory motion, whether it can be in any other microscopic motion. So, but after that, later part of this 20th century, so new mechanics come. So this is quantum mechanics. So there are actually wave properties of the electron was considered, and then so many physical properties have been changed, whether it can be electronic forces, tunneling effect, or quantum confinement. So this has changed the entire properties of the nanoparticle. Yeah, similarly, view of chemistry. Chemistry basically the bond formation and bond making processes. So all electrons are involved. So in that particular cases, whether it can be intermolecular cases, definitely you see the changes of the structure, or if it is intramolecular, say some bonding, maybe hydrogen bonding, or maybe dipole interactions. All these things happens at the nanoscales. So this is the basics of the physics and chemistry where nanoparticles or nanomaterial came into existence and plays at this small scale. In material chemistry, that is very significant. In material chemistry, basically, the nanomaterial or nano device plays a role of the surface. So surfaces will nuclearize electrons. So this has the surface property. Once it is going down and smaller sizes, so it has the surface energy is very high. And definitely, so nanoparticle not only the size, its shape also it matters, and it has the great impact in different applications. Yeah, definitely quantum dots. I already told in nanoscale it is energy is quantized, whether it can be in conduction band or it can be in valence band. So yes, compared to this normal semiconductor counterpart, that quantization is not happening. And here in case of quantum dots, you can tune the size of the energy gaps between valence and conduction band. Accordingly, you can have different catalyzing or any other catalyzing properties of this material. And it is a very observable and lucrative, very attractive, beautiful properties of this nanomaterial because once you synthesize metal nanoparticles, say, so same metal nanoparticle you can have different colors based on the shape and size. Here I am showing the zinc sulfide here, cadmium selenide quantum dots. So this have in different shapes and sizes a series of colors. So this is another aspect, and basically this is due to the surface plasma effect of the delocalized electron over the surface of this metal nanoparticle. Yeah, carbon nanotube has very beautiful structure. It is a lot of carbon, similar to the graphite structure. We have the same honeycomb structure, but if you see, it is very strong, stable. It is almost 100 times more stronger than the normal steel, and 10 times lighter. So it has tremendous strength and properties. If you come to green nanotechnology, so green nanotechnology finds application in different sectors. Alright, in medicine, whether it can be targeted drug delivery, or in case of electronics, whether it can be quantum dot, or whether it can be in sensor technology, this has been widely used. And in case of agriculture, the smart agriculture, whether it can be nano-pesticide formulation, whether it can be nano fertilizer formulation, or whether it can be applied to the soil as a sensor. So this finds application in different fields. Similarly, in environment case also, pollution remediation field, it has been widely used. Well, green nanotechnology synthetic is not so difficult, so we can use different biogenic sources, whether it can be plant origin, or whether it can be microbial organism, or whether it can be compatible biopolymers as well, or maybe some hybrid technology we can adopt. But here, few things are that once we create a nanoparticle or nanocomposite, this has to be stable enough, or encapsulation processes you have to take care such that it can be applied in different fields or to be there. Yes. So sustainability is concerned basically it involves social, economic and environmental sustainability. So this applies similarly to green nanotechnology makers also. You have to prepare a sample in eco-friendly manner, environmentally friendly manner, and the product and the process that has to be less toxic, or it should have the minimum toxicity. And recyclability of the whatever you prepare as a catalyst or material, recycling should be there. This is another aspect of this sustainability. And another is that one, this complete life cycle management of S synthesized particle, whether it can be in the source or it can be disposable level. Yes, definitely in normal synthetic processes, chemical processes, we use the harsh chemicals. In reduction of the metal nanoparticle, we use sodium borohydride or some other compounds which are very much toxic, or maybe solvent system. So it is detrimental to the environment, not suitable for the environment. But in green processes, what we do, we use the lesser sources, biogenic sources, and mostly it works in the water medium. And most important thing is that it requires very less energy consumption, low temperature, low pressure as well. So it is another aspect of our sustainability. Similarly, in minimal or biodegradable byproduct at the end product. Yes, we can use the bio-based plant extract or the microbial products for the synthesis of this nanomaterial. Because in plant system, so lots of alkaloids, terpenoids, lots of polyphenols are there. So this can use as a reducing. So if you tune properly, so you can get good our desired nanomaterial. Yes. So we can use different parts of the plant, whether it can be root, whether it can be bark, whether it can be leaves, so whether it can be flower. So based on this availability of the phytochemicals, so we can choose as a source of extract for synthesizing the nanomaterial of different types, and we can use medical, agriculture, this water treatment or photovoltaic. So basic primary mechanism is that one first you have to reduce the metal salt to nanomaterial, then some growth processes are there, and then finally the encapsulation or stimulation. So let us come to my part very quickly. So once I synthesize a camellia sinensis or whether it can be tea extract, tea polyphenol coated superparametric iron oxide nanoparticle. So these have been widely used or very popularly used in dye degradation processes. So photocatalytic, or it can be used as a adsorbent, good adsorbent for pollution control or pollution management. So this work has been cited well in Nature and their pages. So we publish in a very good journal this work. So in this line, so I am showing some, because basically I started work with the magnetic nanoparticle as a core material. So why I put the different nanomaterial based on different applications. So my area was focused on the organic transformation, organic synthesis. But at the same time, I studied the property of photocatalytic effect, so which can be used in environmental remediation processes. So if you can see the cobalt magnetic nanoparticle, so we started using some main reaction, metallurgical reaction or alkyl condensation like that. So we published in some good journal that time. So after that, some palladium nanoparticle coated cobalt nanomaterial. So this has been widely used in some other significant organic transformative reactions, that is Suzuki coupling or some other reactions. And we also coated the base material was cobalt and coated over a zinc sulfide nanoparticle. So this has been successfully used in photocatalytic type degradation processes. So in all these cases, the most important thing is that we can use this as a catalyst in organic transformation, as well as same catalyst can be used for photocatalytic processes also for environmental remediation within a very short span of time. Low energy consumption. You can even work with the low ultraviolet radiation or sunlight, under the sunlight. So similarly, zinc oxide nanoparticle, cobalt nanoparticle, we have been used in photocatalysis. Similarly, chromium oxide, silicon dioxide, coated iron oxide nanoparticle in some other dye degradation and absorption processes. Or you have some cases in biocide nanocomposite iron oxide nanoparticle also. We have been used in degradation of first green dye, which is the effect on light. So in very recent years, so we use copper sulfide nitrogen biomass derived carbon composite, which have been used as a heterogeneous phantom like degradation of dye. Yes, this is very much important designing of this nanomaterial or nanocomposite. First, once you synthesize the core material, so you first have to synthesize the core material, then over here, so you have to functionalize the material, or you can incorporate other magnetic nanomaterial or other quantum dots also based on their different applications. Right. So these all magnetic nanocomposites, if you see, these have been widely used in heavy metal absorption as well. As at the same time, this can be used in pharmaceutical pesticide, nutrient control, management in soil, and other applications. So there are lots of significant work in this area using magnetic nanocomposite have been widely used in environmental EME. Whether it can be uh, 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 zero valent metal iron or any other metal nanocomposite, or whether it can be in basically super paramagnetic or paramagnetic nanopores with the other composite material. Or you can have, say, in last few years, graphene oxide science is very popular in different applications, and you can have this composite nanoparticle with the graphene oxide as well, and having so many applications in environmental remediation work. Yes, so particularly I have been over so many experience of characterization of nanomaterials in that particular functional area. So you see, once you synthesize the nanomaterial, so you have to characterize the material in a proper way. So most fundamental instrument you have to use the invisible spectroscopy. Once you synthesize the metal nanoparticle, so you get different distinct peaks in different regions. So similarly, FTIR, if you functionalize, so FTIR spectroscopy is used to see the functionalities of the nanomaterials. Similarly, XRD, if you want to study the crystalline styles, so you have to measure the XRD as a scaling tunneling electron microscope. That is very high cost instrument that is not available in the entire Northeast India. But anyway, in some cases, the atomic level, even you can see the atom in particular which is very much important in nanolithography. And similarly, scanning electron microscope nowadays in so many academic institute and research institute is available, and transmission electron microscopy. So these are the very fundamental instruments to study the nanoparticle. Similarly, dynamic light scattering. So if you have the nanoparticle, so this stability study, you have to measure with this light scattering method. Similarly, in thermogravity analysis, you have to study the material with TGA or thermogravity analysis to study the stability of the nanomaterial. Yes, UV visual spectroscopy, you get distinctive due to the surface plasma resonance, and then this is the primary investigation of the synthesized nanomaterial. As I told, this is the single crystal or X-ray diffraction studies. So through this, you can measure the crystal size of the nanomaterial. As I told, functionalization you can study with the Fourier transform or FTIR spectroscopy. Yes, tunneling microscopy, STM, as I told you, this is basically it is on the quantum tunneling effect. The principle is that one. So atom by atom, you can scan the sample and then you can get the atomic resolution with this scanning tunneling microscopy. Yes. Another one is that on atomic force microscopy. So there is a very smallest tip that is up to in the nanoscale. It is there. So you can scan the sample one by one, and you can, because based on the different sample properties, this may have some more underworld forces are there, or you can have the electricity force, and some other forces are there. Based on this, you can get the atomic resolution with atomic microscopy. Basically, there are two scanning electron microscopes. Principle is same one. So scanning electron microscope and another is transmission electron microscope. In scanning electron microscope, energy, power of the electron energy is less. It may be up to 30 electron volt, and scan over the surface in the raster scanning pattern. So once the electron, incoming electron, strike with the sample of the surface, so it gives the secondary emission. So based on the secondary scattering effect, so sample information can be studied in this image form, and you get the morphology of the sample. Similarly, in transmission electron microscopy, the electron gun, this column is very long and energy is very high, and this power of the electron is so high, and before sample is small enough, it penetrates over the sample and it gets at the lower process skin is there, so you can get the structure of the sample. In DLS system, dynamic light scattering methodology, so you can get the data potential as well as hydrodynamic diameter of the sample. So this is basically used for the stability of the colloidal particles, colloidal nanoparticles. Similarly, thermomagnetic analysis, your surface is functionalized in different material, so you can get the thermal stability over the sample at different temperature at different rate. Yes, so different instruments we can use to study the nanomaterial or nano device. Yes, I am showing one characterization technique. This is a cobalt magnetic nanoparticle. So it is a transmission electron microscope image. So you can see the homogeneity of the nanoparticle as inside. At the same time, we can have the selected area diffraction pattern where we can see the atomic what is called atomic flanks, and you can measure this atomic flanks distance. That is called D value. And this beauty of this magnetic nanoparticle is that what it is a quasi-heterogeneous material. In aqueous medium, it is a quasi-heterogeneous or quasi-homogeneous material. In particular, in organic transformation or organic reaction, homogeneous reaction medium is very much effective. So it's once you use this magnetic nanomaterial in reaction, once it is over, so we can separate the magnetic nanomaterial by external magnet. And this activity is shown. Similarly, another example I am showing, it is a zinc sulfide coated cobalt magnetic nanoparticle. So this actually was published in a very good journal earlier. So this nanoparticle we have been using photocatalytic process of degradation. So this is if you see this right hand side, so 4 material is cobalt and over there zinc sulfide coating is here. So basically this morphology characterization is very fundamental to see in nanoparticles. Then only we can go for different applications. Similarly, we see this as very homogeneous, highly homogeneous palladium protein nanoparticle, cobalt nanoparticle, and this has been used in significant organic transformation reaction, Suzuki coupling reaction. And this is we could able to use an aqueous phase, aqueous medium the reaction. Similarly, one report is there, similar analysis using the T waste or T extract. So carbon from the carbon coated palladium nanoparticle we design and develop, and this have two applications. One is organic transformation in Suzuki coupling reaction, and another application is dye-resistant. Say in parametrophenol, what we have shown here. Yeah, green tea nanoparticle coated cobalt or iron oxide nanoparticle. So left hand side you see the homogeneity of the particle, and this corner one is the selected area diffraction pattern. It shows the different kinds of this atomic scale. And right hand side you show a toxic dye, which is basically is a waste of the dye industry, and it can get the degradation within a very short span of time. Within 60 minutes, so it completely degrades the diamond. Yes, in characterization you see there are lots of instruments are involved. So based on your processes, you see if it is some electron microscope or ACM, whether it can be or if it is magnetic particles, so you have to go for characterization with hydrogen magnetic sample magnetometry, or whether if it is fluorescent type nanoparticle, you have to go with the confocal experiment. So lots of analytical instruments you have to use to characterize the nanoparticle, and it gives you the beauty of the sideways. So once you see, you can get 2-dimensional or 3-dimensional nanoparticle, and at the same time you can have the nanoporous nanoparticle as well. So it has it is distributed ordered nanoparticles. So it has different application in absorbing dipole. Alright. Similarly, this is a gold nanoparticle at very high resolution and different shapes. This is a biomolecule this SCM mixture is there images. So it is very high resolution, 200 nanometer resolution. So you can get distinct biomolecule morphology. Similarly, nickel catalyst incorporated carbon nanotube we can see in electron microscope. So it acts as a catalyst in different organic transformations. At the same time, if suppose we get an image in that particular area, we can get its elemental composition as well. So it is called energy dispersion or image spectroscopy. So this is an image of single one nanotube. Yeah, application. Let's come to its application. In application part, once you synthesize in the green nanomaterial, so you can have used as a nanofertilizer, nanopesticide, or a nanosensor, or as a nano carrier as well. So these are very much important because in agriculture faces multiple modern challenges: nutrient efficiency, soil degradation, pest resistance, or environmental pollution. So nanoparticles have the crucial role they play in this area. As I said, zinc oxide nanoparticle are synthesized using neem leaf extract, so they improve the zinc availability in soil. So this benefit is that one, it has a control nutrient release, increase absorption by plant roots, and reduce bleaching and runoff. So these are some benefits of this nanoparticle. Similarly, nanopesticide also. The slow and targeted release of active ingredients, that is the most significant advantage of using the nanopesticide. Similarly, it has lower toxicity to non-target organisms. Here is an example of silver nanoparticle as synthesized from a plant origin, and it has different antifungal and antibacterial properties as well. Similarly, iron oxide and titanium oxide nanoparticle, so this has been used as a nano carrier for micronutrients. So this can be called as a precision control agriculture because nanosensor detect the soil moisture, pH, and nutrient level in real-time analysis. So what APJ Abdul Kalam said, the sustainable agriculture begins once science listen to the language of soil. So soil is very important. Once you design and develop for the nanosensor for the soil, so it has highly restricted in nanotechnology or sustainability. So let us come to nanomaterials, green nanomaterials or nanoparticles in various environmental sustainability cases, whether it can be metal absorption, it can be widely used or have been used, it can have pharmaceutical absorption or degradation, so it can have agrochemicals management, or it can have this degradation or absorption of radioactive waste. So in all these cases, this nanomaterial acts as an absorbent or is a photocatalyst or photocatalytic material. So basically, photocatalytic absorption processes. So this depends on the barrier energy of the valence and conduction band. So here, once you synthesize the material, so under the irradiation or maybe under the sunlight, so it gives you the very easy separation of the hole and electron pairs. So electron is very high energy and is negative organic contaminants up to this through some intermediate non-toxic water or carbon dioxide. Completely break down the molecules. Here this already I showed earlier also. So heavy metal removal of the green nanomaterial has been used, whether it can be through degradation or whether it can be through advanced technology. Once you use, you can separate the magnetic nanomaterial with external magnetic field. Similarly, in air pollution also, cerium oxide and copper oxide nanomaterial have been widely used, as well as for absorption of the volatile organic compounds, which is existed in our environment. So definitely there are few challenges are here. So difficulty controlling the size and shape. And one challenge is there, that is the from the laboratory scale to pilot scale. So that lots of work has to be done. So lack of detailed toxicity study, and there are some standardization and regulation process yet to be adopted in open sustainability mechanism. So some future directions are there, integration with circular economy principles, so machine learning for process optimization. So now AI technology is there, so such that should have incorporation with AI technology to this green nanotechnology such that we can get optimized process. And next, the hybrid green biotechnological synthetic approaches should be addressed properly to get this benefit to our future generations. Yes, I come to the summary part. So here the green nanotechnology encompasses nanotechnology as I said with the green chemistry, which is safe, efficient and clean technology, and we get the sustainability which is related to social, environmental and economic balance. And this green nanotechnology widely applied in agriculture, whether it can be nanoparticle or as a soil sensor or maybe water for the satellite purification of clean water technology, or whether it can be in energy, solar energy, or it can be in medicine, drug delivery systems, or whether it can be environment pollution control processes. Well, green nanotechnology is gives a bridge between the nanoscience and sustainability. So efficient resource should be used, reduce ecological footprint, and smart sensing and pollution remediation are the environmental management process which will have to be addressed. So green nanotechnology is not just about making things smaller, it is about making life better. So in this smallest thing, we discover the largest possibilities. In nanotechnology, what are there? Possibilities are always there. When science serves nature, sustainability becomes invisible. So by saying this, so I am concluding this topic. Basically, I am giving just like a popular talk, not just hardcore research work or activities what I have been doing or done earlier. So this is basically the introduction of the nanomaterial, particular to green nanotechnology, its design and development, for its characterization techniques, as well as its different applications. Yes, so our mind should we should have the right attitude. Yes. So once our mind is green, then only we can see green. So this is very important. So our mirror, our glass should be clean enough so that we can open our window or we can see through our window as the green material, whatever is very much important for our future generation, our future generation. Well, though it is not relevant to this work, so and because or to have a right attitude, we should have a green mind. So to have a green mind, we must have the habit of reading. So basically, once I go from this scientific talk or any popular talk to college or university, so this slide I am showing and I am reading also. So some very good book which is highly recognized worldwide. So I translated into Assamese language and most of these are very highly popular books. So I am basically I am not this present time I am not doing research basically. So I am not in the research, though I am involved in academic work. and also my colleagues are guiding MSc or PhD student as well. So I am not taking till now because my basic interest is focusing on this one, so that I can contribute, I can, which such that people can have right input to have this habit of reading, and that is also another sustainability case, so they can have a good attitude, good mind and mindfulness basically, so such that the whole environment will be green and sustainable. So these are the things. So some books I already heard also, and many of it over 12 books, very recognized books. So I translated it into Assamese language, and they have popularized. So thank you so much for your time.
Thank you very much, sir. Now the session is open for interaction. Our participants may ask their questions.
Yeah. Sure. Please. If you have any question, you can ask please. I'll try to.
So thank you very much, very nice presentation, excellent work. And last part was you have attracted more light, showing all this your work. So my request to you is that, could you please accept some of our students for internship for on this in this particular area? গবেষণা আমাৰ বহুত কলেজত হয়, ইয়াতো সায়েন্স নতুনকৈ হৈছে, মানে নতুন মানে কি কেইবছৰমান হৈছে, গতিকে যিকোনো ষ্টুডেণ্ট যদি এইটো এৰিয়া লৈ কেমেষ্ট্ৰি ইনিচিয়েটিভ নেনো টেকনলজি মানে সৰু কথা এটাকে যদি শিকাই দিয়া যায়, হাউ টু ক্ৰিয়েট দোজ পাৰ্টিকলছ এপ্লিকেশ্যন পাৰ্টিকুলাৰ ৰিলেশ্যন, তেনেকৈ অলপ অলপ যদি আপোনালোকে হেল্প কৰিব পাৰে, IIT is so close and close to the heart of the people of Assam. So therefore I am requesting you on behalf of all of us. But our interest we should show our interest. Which to be our board Sanita, who carries Assam oxygen, to be governor boards are present to Pulsa. In the next time I want to see that you could learn from him, from IIT Guwahati, learn from Professor Chakraborty, because they were in a nearby college here. So therefore, like her, so many talented faculty members here. Faculty members are so talented because I was in the selection committee member. It was so hard to select one, maybe from 20. All were equally good. Then it was a tough. Okay, it was very tough for us. Therefore, my request to both sides, as a resource person, you will help, and as a learner and worker, you should go forward. And I must know that somebody is going to you. And also, how to get all these books.
So it is, copyright processes. It is a copyright process. Actually, I started the translation was during COVID. Earlier, I did not. I write in magazine or newspaper, but I did not publish in book. You asked about how to get this book. So all books are available in Amazon and in Pan Bazaars, major publishers or any distributors.
Any more questions? So if there is no further questions, we are about to wind up the session. Thank you, sir. The session was very informative. Creating such a small particle can make a higher level sustainable development. So this is a very important and it has a broader scope of research for academicians. It is going to have a good output from this seminar. So thank you very much, sir. And and sir is also very much dynamic, including research. He has also authored many books, so it is going to have a good effect among our students. Thank you very much, sir. So with this, I I want to wind up the session. After the session, we are going to have our lunch. So I request all the participants to head towards the canteen. Post-lunch session, we had technical session 4 and 5. Due to the HS exams, we had to adjust it with the technical session 3. So we have merged it, and already we have completed all the OPs and PPs before lunch. So after lunch, we will have valedictory session in the new conference hall. Thank you.